Question number 13. So GATE 2003 2 marks question. A part is shown in the figure. He has given one diagram. So this is a diagram. It's like coupling. It is like looks like coupling. QWR. This is P. So he has given P equal to 35 plus or minus 0.08 mm, Q equal to 12 plus or minus 0.02 mm, R equal to 13 plus 0.04 minus 0.02. With 100% confidence, the resultant dimension W will have the specification. So we need to calculate W dimension. So how do we get it? So first, maximum limit P max equal to 35.08. P minimum equal to 34.92. So if you subtract minimum values of Q and R from P max, you will get maximum value of W, right? Subtract 35 minus, suppose 35 is one thing. Similarly, Q max, R max. So W max equal to P max minus Q max plus R max. Similarly, W minimum equal to Q minimum R minimum. So if you simplify this, you will get option which satisfies 9.99 plus or minus 0.03. Answer is option A. Similarly, there is another problem on taper measurement. In 2010 they asked. Question number 2. ME 2010. He has given the taper hole is inspected using the CMM with a probe of 2 mm diameter at a height 10 mm from the ground. From the bottom, 5 points are touched and a diameter of circle is obtained as 20 mm, and similarly 40 mm diameter at a height of 40 mm. The given problem is it's taper hole, so symmetrical taper. This is height z equal to 0, z equal to 20, z equal to 40. So here diameter is 20 and here diameter is 40. What is the diameter at z equal to 0? That is a problem. So we need to calculate this one. So to get that, from symmetry of triangles, so we can calculate this way. This is what is the value of this? Similarly we can calculate this one. First theta, this is also theta. This equal to 40 minus 20 by 2. So that is 10. So if first calculate theta, tan theta equal to 10 by adjacent side is 20. So theta equal to tan inverse 10 by 20. From triangle, another triangle like this is O A B. From triangle OAB, tan theta equal to opposite side, we don't know, AB by adjacent side is 40. So AB equal to 40 tan theta. So that's equal to, substitute theta equal to 40 tan of tan inverse means 10 by 20. So you will get value, tan will go cancel. So 1 by 2, 20, AB equal to 20. Small correction, here it is z equal to z1 is 10, z1, z2, z3. So z2 is 10, not 20. So our formula will change as 30. So this value is 40 by 3. That is AB. So if you want to calculate the diameter at Z, 40 minus 2 into 40 by 3 equal to 40 by 3. That is equal to 13.3 mm. So diameter at the bottom is 13.3 mm. So simple, you don't need to remember any formula, just use trigonometric functions, you can solve the problem. So 2 marks question, anybody can solve this. Next, screw thread measurement, last topic. So what here in screw thread, upper diameter and lower diameter or maximum diameter and major diameter, minimum diameter, you can easily measure with normal vernier calipers, all those things. But if you want to measure under effective diameter, then you have to use some different methods. So major diameter, this one is minor diameter, major and minor you can easily measure, and you can use bench micrometer and floating carriage micrometer to measure major and minor diameter. Major and minor diameter meters are measured using bench micrometer or floating carriage micrometer. Pitch of the screw thread is measured by using screw pitch gauge, tool maker's microscope, optical projector. Pitch is the distance between two successive points in a thread. Pitch of screw thread is measured using screw pitch gauge, tool maker's microscope, any of this. Optical projector. Next, effective diameter. What is effective diameter? We know major diameter and is a diameter measured at the addendum, and minor diameter is diameter measured at the addendum. So what is effective diameter? This is important. Effective diameter is imaginary diameter, is also called, it's an imaginary diameter at which the thickness of thread is equal to the gap between two threads. Imaginary diameter at which the thickness of thread is equal to the of thread is equal to the gap between threads. This is called effective diameter. For example, in diagram, so that this is a gap between threads, this is the thickness of the thread. See, at the point at which both are equal is called imaginary diameter. How we measure? There is one method, best wire method. Best wire method is used to measure imaginary diameter. How we measure? So for this, how to calculate the pitch or effective diameter using best wire method. So we need to calculate the best wire diameter. So here, this is the center of the wire and this is the point touching. So if this is making an angle alpha, so here also alpha angle will be there based on the similarity of angles. I will draw it somewhat bigger, then it will be visible to you. So we need to measure the best to effective diameter. For that we use best wire method. So this is a diagram. This is the center of the wire. This is the angle. So based on the property of angles, alpha both are same. So this is center O, A, B, C. From the triangle cos alpha equal to adjacent side is AB divided by hypotenuse is OA. So cos alpha equal to adjacent side is what? P by 4, pitch by 4. Pitch is the distance between two successive threads. So if this is P by 2, half of that is P by 4. P by 4 divided by OA is radius of the thread. R equal to P by 4 1 by cos alpha. Multiply with 2, you will get diameter. 2R equal to P by 2 secant alpha. 2R is nothing but D. D equal to P by 2 secant alpha. So D is the effective diameter. Effective diameter of screw. Effective diameter of wire. And alpha is angle between the threads, and P is pitch of the thread. this is about effective diameter calculation, best wire, what is the best wire diameter, and this is effective diameter of the wire. So in metrology you will get questions only in fits, limits, fits and tolerance. They never asked in the remaining topics like screw thread measurements and gauge design, all these things. Gauge design is again similar to the limits, fits, tolerance. So one, if you are clear about the calculation of limits, fits, tolerances, then almost 90% chance you can solve the question from metrology. There is very less chance they will ask the question out of the limits, fits, tolerance. Okay, thanks.